You know that feeling when you're staring at a math problem and it just looks impossible? But then you find out there's this one simple trick that just cracks the whole thing wide open? Well, that's exactly what we're talking about today. It's a super clever technique for factoring polynomials that seem way too complicated at first glance. Let's get right into it.
So here's what we're going to do. First, we'll see how these problems are basically wearing a costume. Then, we'll learn the secret code to spot them every single time. After that, I'll give you a 5-step master plan. We'll put that plan to the test with 3 different examples, and then we'll wrap up with the common mistakes and the big takeaways.
All right, first things first, let's set the stage with the main puzzle here. We're going to look at a problem that looks really tricky on the surface, but trust me, it's hiding something you already know how to handle.
Okay, so look at this thing. It's a polynomial with 3 terms, but that first exponent is a 4. So right off the bat, you're probably thinking, what do I even do with that? Your standard factoring tricks for quadratics don't seem to apply. Factoring by grouping doesn't look like it'll work either. Looks like we're stuck, yeah?
Well, here's the big secret. This isn't some scary, new kind of monster problem. It's just a plain old quadratic equation that's playing dress-up. And I promise, once I show you how to see through the disguise, you'll start seeing it everywhere.
Okay, so how do we spot the disguise? How do we see through the costume? It all comes down to one really simple, really crucial rule. This is the key, the aha moment that's going to unlock everything for you.
This is it. The secret code is a 2-to-1 ratio. Seriously, whenever you see a polynomial with 3 terms, just look at the exponents. If the biggest exponent is exactly double the middle exponent, boom! You found yourself a quadratic in disguise.
So the fancy math name for this is quadratic form. Think about your normal quadratic, right? But instead of a plain old x, you've got some other stuff in there. The key is that stuff is squared in the first term, and it's just by itself in the middle term. That's our 2-to-1 ratio in action.
All right, so we know how to spot them. Now, what do we do about them? We need a solid method. So let's build our toolkit with a foolproof 5-step master plan.
This 5-step process is our roadmap. It's basically a simple substitution trick. First, you grab that variable part from the middle term and just call it u for a minute. Second, you rewrite the whole problem using u, and poof, it magically turns into a simple quadratic you already know how to factor. Third, you factor it. Fourth, and this is super important, you have to swap your original expression back in. And the last step, the one everyone forgets. Always, always check if you can factor it even more.
Okay, theory is great, but let's get our hands dirty. The absolute best way to get this down is to see it in action. Let's put our 5-step plan to the test right now.
All right, back to our first problem. First check, exponents are 4 and 2. Is 4 double 2? You bet it is. So we know for sure our master plan's gonna work here. Let's do this. Step 1. The middle part is x squared, so we're just gonna say u equals x squared. Step 2, rewrite it. X to the 4th is just x squared squared, right? So that's u squared. Now our problem looks so much friendlier. It's just u squared minus 5u plus 4. Step 3, factor that. Easy enough. That's u minus 1 times u minus 4. And now for step 4, we gotta swap the x squared back in for u. Now hold on. This is the exact spot where so many people stop. They think, great, I've got 2 factors, I'm done. But remember step 5? That last check is honestly the most critical part of the whole process. Don't skip it.
And look why. Both of those new factors, x squared minus 1 and x squared minus 4, should be ringing some bells. They are both a difference of squares. That means we can break them down one more time, and that gives us our final, completely factored answer. See how crucial that last step was?
Let's try another one. This one looks a little spicier because it's got a number out front, a leading coefficient. But don't let that fool you. The process? It's exactly the same. First, the exponents check, 4 and 2. Yep, that's our 2-to-1 ratio. We are cleared for takeoff.
So, just like before, we let u equal x squared. That turns our problem into 2u squared plus 3u minus 9. We factor that, which gives us 2u minus 3 times u plus 3. Now we swap the x squared back in. And we do our final check. Can these be factored further? Well, 2x squared minus 3, nope. And x squared plus 3 is a sum of squares, not a difference, so nope again. We're actually done. That's it, fully factored.
Okay, ready for the boss level? Don't freak out when you see that x to the 6th. What's our rule? What's the very first thing we always do?
We check the exponents. We've got a 6 and a 3. Is 6 double 3? Of course it is. So guess what? Our same exact trick is going to work.
Now pay close attention to the substitution here. The middle term is x cubed, so this time that's what u is going to be. And since x to the 6th is just x cubed squared, our problem becomes a nice clean u squared minus 7u minus 8. We factor that, get u minus 8 times u plus 1, and then we substitute back to get x cubed minus 8 times x cubed plus 1.
And here we are again, at that all-important step 5. Time for the final check. Are we done? Well, if you remember your special factoring formulas, these should be jumping right out at you. We have a difference of cubes and a sum of cubes, a 2-for-1 deal.
So we apply those special cube formulas, and we get this beast of a final answer. This is a perfect example of how different factoring techniques can be layered on top of each other. Spotting that initial quadratic form was just our way to get a foot in the door.
So we've seen the method in action. We've seen how powerful it is. Let's wrap this all up by hitting the highlights. What's the biggest mistake to avoid, and what are the most important things to remember? Listen, if you take only one thing away from this explainer, let it be this. Do not stop too early. That final check is everything. After you substitute back, you have to ask yourself, can I go further? Is this a difference of squares, a sum or difference of cubes? Always, always push to factor completely.
And for anyone out there thinking, yeah, but where am I ever going to use this? Get this, quantum physics. No, I'm serious. The energy levels of quantum systems are described using these exact kinds of polynomials. Physicists literally use this factoring method to figure out the fundamental properties of our universe. How cool is that?
And that leaves us with a final thought. This whole process was never just about factoring. It's about a bigger idea, recognizing a familiar pattern in a place you didn't expect to see it. And that skill, that goes way beyond a math classroom. So the question to leave you with is this. What other complex-looking problems in your life might just be simple ideas in disguise, just waiting for you to find the right way to look at them?